Remember the 5th of November, the Zen 3 launch and benchmark plots. AMD has been relentlessly, resolutely working on real results. They've become revered religiously, but worshipped by rabid rabble clouds results and must be rebuffed. Now with results restrictions rescinded, Red rides again, and we with real results. Ryzen is released. But shall we rave or shall we rant? Restlessly, I have been racing to record results. Records broken. Rapt was my reaction as I read the range of scores and retested. Can this radical reversal be right? It's raucous. Ryzen rises with resplendent relief because registers have been rebuilt, and now RAM latency is also in retreat. Zen 3 is a re-architecture, a reimagining, a revitalization. Sure, Ryzen has been wrought wryly, but can it replace the recumbent, reigning rakish processor, even as their ramshackle process node is rising? With past wrongs in remission? I say they're reeking of rancor from recently released Ryzen. No, a rocket! It's wrecked! ROTFL-MEO. Red's robust, resolute. It's no ruse. Nothing is in regression, which is quite an accomplishment for a re-architecture. Rather, these rare frame rates are the realized results of that ruthless re-engineering, really redefining expectations. These are the revelations relayed from Robert and the rest, revealing a raging rampage of frame rates and raw performance. Revolutionary. But can it be recommended? Worthy of remuneration? Rewind, reshare, receive my review with relevant details, because we must all ruminate on the many ramifications. And I'm rarely reticent and often rambling, so let me restate. Red again reigns. Well, hello and welcome if you're new. Sometimes we like to have a bit of fun. I was inspired because this is kind of an historical moment, an inflection point, if you will, because this processor, the performance improvement, how far AMD has come since really Ryzen 3 years ago, is unbelievable. It's literally unbelievable that there was that much performance available when, basically everybody in the semiconductor industry were hitting like laws of physics problems, speed of light problems, switching speed of silicon problems, signal propagation problems in silicon, and so kind of inspired. Don't worry, we're going to get on with the review in just a second. The last thing that I'll say is that in these benchmarks, like the artificial benchmarks are the things that improve the least. Like there's still a ton of improvement, a crazy amount of improvement, but a lot of detractors from AMD would say, oh, it's up to the real world application performance. And there's kind of something to that. I mean, real world applications are kind of single thread dependent, and then some of them become multi-core dependent. And so it's really, you got to have both. And AMD's got both. And it's really incredible how much their single core, single thread performance has improved for those kinds of scenarios. It's literally unbelievable. But let's get on with the review. AMD is releasing their new Ryzen 5000 series processors, and these processors now also take the gaming performance crown as well. So for launch, I've got the 5900X and the 5800X. But don't worry, I've got a lot of content coming about the 16-core 5950X and the 5600X as well. Gaming, and specifically high frame rate gaming, was one of the last holdouts for Intel. AMD was already winning on most other benchmarks and the value proposition. AMD launched new higher clocked XT versions of their Zen 2 Ryzen 3000 processors just a few months ago, and those CPUs really closed the gap between Team Red and Team Blue in that gaming performance scenario. Zen 3 is a ground-up redesign. It is an internal reorganization and a re-architecture. It is enormous, and it is unusual to see this much of a performance gain over Zen 2. To see this much performance uplift in a generation is absolutely unheard of. Zen 3 is a brand new compute chiplet design, but that drops right into the existing, chiplet-oriented designs that we saw on Zen 2. It's the same lithography process as Zen 2, and AMD and TSMC, AMD's production partner, have a lot of experience on that fabrication process. And so it really shows, because the thing they had to figure out here was the new design, of Zen 3. And Zen 3 has a lot of innovative design features over Zen 2. And we'll talk more about the design wins that led to double-digit % improvement in performance benchmarks like, instructions per clock. It wasn't really any one thing. It was many different things that were addressed, and each thing contributed significantly to the overall performance gains from Zen 2 to Zen 3. Now, these gaming scores that I'm about to show you wouldn't be believable or credible without knowing the context, I think, and the whole Zen 3 redesign. I mean, gaming, and specifically high frame rate gaming, was one of the last holdouts for Intel, and AMD was already winning on most other benchmarks by the time they released the XT processors based on the Ryzen 3000 design. But even as they released those XT processors, some games, like Far Cry 5, still struggled. And the reason that games like Far Cry 5 struggle is because they don't really take into account the architecture of Zen 2 in how the game is doing stuff under the hood. It doesn't really take into account the fact that, you might have processes running on a different core complex or a different chiplet. It doesn't really deal with that. The main difference between Zen 2 and Zen 3 is, like, you look at it on paper, it's like both Zen 2 and Zen 3 have 32 megs of cache, but on Zen 2, each group of cores, there was basically 4 cores per group. On a 12-core processor, you'd have 4 groups of 3 cores, and games like Far Cry 5 would try to redistribute the load evenly across the processor, which led to some contention and maybe didn't make the most effective use of that cache memory. Well, Zen 3, 32 megs is available to a single core. So we now have a core complex that is fully 8 cores and fully 32 megs of cache. By contrast, an Intel CPU like the 10900K would do better on games like Far Cry 5 because of its relatively monolithic design. So now with 2 6-core chiplets in the 5900X, that's 64 megs of L3 cache, and a single 8-core chiplet with 32 megs of cache, both of these processors really shred in games. But it's not just the cache. There's actually a huge number of improvements, and we'll talk about that more in the technical section. But for now, gaming. Focus on gaming. Gaming. That's why we're here, right? Gaming performance. So, Far Cry 5. Let's take it back there. That's one of our troublemakers. Let's get that troublemaker out of the way. Goodness gracious, the Far Cry 5 performance is at parity or slightly better than our Intel test systems. Now, I've done testing with both the Intel 10850K and a 10900K to show that there isn't much of a performance difference between those CPUs because the 10850K is a way better deal than the 10900K. And if we look at 1080p, that high frame rate gaming holdout, there's virtually no performance difference across any of these CPUs from AMD or Intel, and generally the performance was either better or within margin of error on Team Red. The same was true when you step up from 1080p, a resolution of 1080p, to 1440p. If anything, AMD is even showing more of a performance advantage here over their Intel counterparts. And keep in mind, this is the problematic games like Far Cry 5. Well, what about Tomb Raider? Yeah, Tomb Raider performs almost identically across all of these CPUs with similar 1% lows and 0.1% lows, and if anything, is now favoring AMD. It looks pretty much the same with Horizon Zero Dawn, Tom Clancy's Wildlands, and Borderlands 3, at least at 1080p and 1440p. If anything, these games are showing favor toward AMD. One game, PlayerUnknown's Battlegrounds, which historically has been one of those quirky games, an Intel holdout if you will, for years, is doing way better, shockingly better than Intel here. Probably because you can load the entire game into that 32 megs of L3 cache. Switching gears a little bit to artificial benchmarks, let's talk about TimeSpy. TimeSpy is an artificial benchmark from 3D Mark. It's really the only gaming benchmark I found to show any real meaningful difference between Team Red and Team Blue at about 1,000 points on the CPU score. However, the GPU score was higher on test 1 with Ryzen. Does that mean that Ryzen can better feed the GPU than Intel, even though the specific thing that TimeSpy was testing on Intel is a little better on Intel? The CPU component of TimeSpy was better on the Intel system, but the overall score in TimeSpy was still better on Team Red. I mean, that seems important to note. So I sure, I don't know. I don't know what to make of that. With Firestrike, it's pretty much the same. The physics scores were consistently higher and much higher on the Ryzen systems, and maybe the GPU tests show that the Ryzen CPUs were able to keep the GPU fed a little better than their Intel counterparts. It's a win for AMD, or a push pretty much everywhere. Now, it is worth emphasizing that the Intel CPUs here are 10-core CPUs, and they were met or bested even by the 8-core 5800X. Ouch. Is 8 cores the new 10 cores? Let's talk about productivity, and specifically the one place where AMD was not doing as well as Intel. Places where single core performance and multi-core performance both matter. Things like CAD, and if you can believe it, web browsing. Web browsing is a surprisingly computationally intensive task when you look at what's happening under the hood, especially if you've got a lot of ads on the page. So let's tackle web browsing and user productivity first. Web Expert, ARES 6, and Speedometer, I think it's Speedometer, I mean it's not supposed to be speedometer, right? In the past, Intel systems were faster by a few milliseconds or more than their Ryzen 3000 counterparts, and really that's down to memory latency and some other architectural differences between Intel and AMD. Not that the Ryzen systems offered a bad experience, it's just that, that experience is exaggerated in these benchmarks. But now the benchmarks are showing pretty significant gains for AMD. And these benchmarks are kind of meant to represent how the system responds to interactive tasks and highly dynamic processing, like surfing web pages and doing lots of heavy JavaScript. Things like archive.org running Windows 95 and JavaScript emulation in your browser, which is really awesome. So let's talk about big data processing and the whole CAD thing as well. It was a similar story to the whole web interactive. It kind of needs to be bursty, kind of needs to be interactive. I mean, CAD needs a lot of horsepower. You'd think that it does, and it definitely does. But some parts of the CAD workflow depend on those tasks that are more like stuff happening in a web browser. So you have to be able to switch context really quickly, doing stuff that's, kind of lightly threaded, but then also being able to, bring the pain and queue up, 8, 10 cores at once and be able to do that in a millisecond. So with CAD and more cores, you can get a benefit from more cores to a point, but eventually it becomes the only thing that really helps you is just the rendering tasks. And you want the actual, doing the work with CAD to be good and low latency and really nice single thread performance. So enter the SpecUperf benchmarks. Now, some of these benchmarks are just around pure rendering type tasks, and that's where AMD would do well, those rendering type tasks, because those scale to multiple cores really well. But some are around that busy thread problem that exists. And this is where historically AMD hasn't done as well, at least not as well as the competition. I mean, they've been fine. It's not been hugely bad. It was just not as good as the competition. Well, here we now see that the tables have turned. With the Ryzen 5800X, it's at parity or better than the 10-core 10850K. And in some cases, it's much better than the 10850K, even though it's only 8 cores. Is 8 cores the new 10 cores? Seems like I've said that before. The same seems to be true with Autodesk products. The 5800X is basically at parity with, or slightly better, in the AutoCAD C2015 benchmark lineup. Overall, the 5800X is about maybe 10% faster there. That's pretty nuts. I mean, if you look at Revit, at the architectural program, and simulation and some other things, for things like model creation, export, and render, the performance uplift ranges from 1% faster to 8% faster, with 2 less cores. SolidWorks overall is also about 8% faster, with simulation being the best at about 20% faster, with 2 less cores. How did they do it? Isn't it true that the larger cache pool would actually add latency, and the chiplet design also adds latency, versus the monolithic design of Intel? And to be sure, if you just measure memory latency, the Intel CPUs are still faster, but it doesn't translate into real-world wins anymore. So how do these Intel CPUs with their, 50 nanosecond and under memory latencies not win? Let's get technical. Yeah, I was channeling Darkwing Duck a little bit there. Let's get technical. So AMD says the instructions per clock uplift is a geo mean of 19%. That's a lot. What does that mean? What's geo mean? Geo means just a fancy way to say that this is the central tendency in a larger set of numbers. So if you look at stuff that's going to be in the middle, it's not really right to call it an average, but it's sort of in the middle. So there's some things that are going to be worse than a 19% uplift in instructions per clock, and there are some things that are going to be apparently way better than 19%. So yeah, AMD included gaming performance in their IPC uplift measurement. And some of those edge case games from before, like PlayerUnknown's Battlegrounds, really tipped the scales in AMD's favor, because PlayerUnknown's Battleground, like if you look at the performance between, Zen 2 and Zen 3, that performance uplift from Zen 2 is much more than 19% if you're looking at the performance of just PUBG. So other applications like Pavre, where AMD's prior gen hardware, Zen 2 was already pretty well optimized, still show IPC gains on the order of like 10% or approaching 10%. I mean, even that in IPC gain terms is like, it's huge. It's enormous. It's a virtual planetoid. It's got its own weather system. Also included in that geometric mean were performance tests like W prime, CPU Z, 7-zip, passmark. Some of it's benchmarks, some of it's, most of it's artificial, but some of it's real world. For the games, they also included Dota 2, Metro Last Light, and many other games. Some of the games did not have nearly as much performance improvement, but I can't help but notice that the far right-hand side of the graph, the things that show the most performance uplift, they're all games. Even things like Cinebench R20, which I tested, showed a significant performance uplift. I decided to do testing at a whole bunch of different clock speeds. So Cinebench R20 showed gains of about 12.3%, give or take, but Cinebench R15 showed gains of about 18%. And that was linear with clock speed. So testing the 3000 series and the 5000 series at locked clocks of 4 gigahertz, 3.75 gigahertz, 3.5 gigahertz, 3.25. It is perfectly linear. And overall, it's a 12.3% to 18% performance gain, depending on if you're running Cinebench R15 or Cinebench R20. So that's a lot. So remember, I keep saying Zen 3 is completely new. Part of the IPC uplift here is that Zen 3 has new stuff in silicon for doing specific tasks. And so if they added stuff in hardware to do those specific tasks, there's a tremendous performance uplift, and they have. Our testing was performed on a system with 32 gigs of 3600 megahertz memory, 3600 mega transfers per second, with CL16 timings. So really, nothing too exotic. CL16, 3600 mega transfers, half of 3600 Infinity Fabric. That ground-up redesign is the special sauce. And ground-up redesigns are a lot of work. They put all the lessons learned into the new chip from Zen 2 and Zen 1 and literally everything. Ryzen and the work around the Zen architecture since 2017, let's face it, it's not been trouble-free. Things like the Ryzen 1000 series segfault bugs, USB chipset issues, more USB chipset issues, issues with partner motherboard implementations, memory topology tweaks, the random number generator. There've been a lot of things, but what's been key through all of that is that AMD has learned from all of this and gotten so much better. At least that's what I've been seeing on the outside in looking at Zen 3. And that's great. It's great to have a company that can keep calm and Zen on. Take the issues in stride, work through them, fix it, reincorporate those lessons learned into the next product. Zen 3 even adds new instructions for better security at the silicon level. And we'll talk a little bit more about that. Because the single core has access to all 32 megs of L3 cache, the IPC uplift, that's pretty cool. But the IPC uplift actually breaks down into improvements in cache prefetching, improvements in the execution engine, improvements to the branch predictor. The micro-op cache has changed. The front end has quite a lot of changes. And the load store system has been changed. So for load store, for example, they went from 2 loads in 1 store per cycle to 3 loads in 2 stores per cycle. The translation look-aside buffer got 4 more table walkers, so that'll help the cache be populated with stuff from memory that's going to be needed. The branch predictor, with its much faster branch mispredict recovery and accuracy improvements, means that you're not going to have as many wrong or incorrect branch predictions. You see that AMD refer to that as no bubbling. It's like the branch predictor doesn't have any bubbling. It's like, well, it's because it's doing a lot more work now. There are lots of improvements in both the integer and floating point execution units as well. Improvements that improve executions per cycle and widen the pipes that are used to feed those facilities. Used to be a 5-cycle FMAC, but now it's down to 4 cycles. So it's doing more per clock right there. That's already a pretty big uplift. Store to load forward prediction has been improved. Some loads can be reordered to lower latency for instructions that really need the data. So you have to understand that the more cache a processor has, the more latency it takes to get through all of the cache. So the latency as measured by Ada64 is actually lower on Zen 3 than on Zen 2, even though the Zen 3 cache takes an extra about 7 cycles because it's larger. But with the other improvements that are on the chip, that the extra number of cycles latency is more than offset because literally everything else is better. I mean, strictly speaking, the massive L3 cache is technically, it's a victim cache. And what that means is that the data ejected from the private 512 kilobyte L2 cache that exists in each CPU core ends up in the L3. So if it won't fit like in the very local cache that the CPU has, it ends up in this giant pool of L3. So when one core needs something that another core already has, but it hasn't yet been evicted from the L2 to the L3, AMD has shadow tags out in the L3 so that the L3 can go and get the data from the other core instead of main memory, because getting it from main memory is a relatively slow last resort, which is pretty awesome. So even though it is a victim cache, it's not exactly a victim cache feature. That's pretty awesome. They also increased the bandwidth up to 64 outstanding misses per core and up to 192 outstanding misses from main memory. That's a pretty fat pipe. One of the security features that I was mentioning before was a shadow stack for ROP attack protection, memory protection keys, and some other hardware protection for Spectre type attacks. So yeah, memory keys for normal pedestrians now, it sounds like. Now for Ryzen 5000, they didn't need to figure out the chipset or the chiplets or anything else. The new Zen 3 chiplets just drop right in where the Zen 2 chiplets were, and then they just repackage it and everything else. Speaking of which, what about the memory controller and the I/O die? Well, that's the other brilliant thing with AMD's approach. They haven't changed. They didn't have to worry about it. They got all that working with Zen 2. Now with Zen 3, they can focus on the Zen 3 chiplet. Literally none of that changed. The package is the same. Everything else is pretty much the same. Now the thing that is a little different here maybe is that there are manufacturing improvements. Tolerances are better, know-how is better. You could probably get higher memory clocks out of the Ryzen 5000 series than prior. 3800 and 4000 memory means your Infinity Fabric could actually go up to 2000 megahertz. I was able to achieve 3800 no problem. I was able to achieve 4000 with quite a bit of fiddling, which is pretty awesome. I did try overclocking. I did try for a lot of things, but your best bet for overclocking is not to try to override AMD's boost algorithms. You'll just make the performance worse. And instead, focus on memory speed and latency. 3800 megahertz memory with good timings was all I needed to outperform our Intel comparison system in literally everything, even games where it was a push. But we'll look more in depth at that later, because there are a couple of asterisks there. I think 3800 megahertz memory is the new sweet spot, and more on that will have to come later. But 3800 megahertz memory, CL16, ooh, that's nice. Now remember, for our testing, we're only using 3600, which should be possible, but remember, 3200 is the fastest available speed that is officially supported. So last up is pricing. AMD's pricing here looks like a $50 price bump, and you lose the bundled CPUs in all of these CPUs except for the 6-core 5600X. But I'm not really sure it is a $50 price bump, is it? I mean, maybe. In their benchmarks, it looks like the 8 cores is the new 10 cores, and 12 cores is the new 16 cores. At least the 12-core, 5000 series CPU, our 5900X, is really close to the 16-core 3000 series CPU in a lot of cases. Yes, the 16-core is a little faster in a lot of cases, but anything that is even remotely dependent on single thread, the 5900X takes the crown. If you look at it on a per-core basis, yeah, okay, maybe it's a price hike. But with the new Zen cores, you're getting a lot more per core in both single and multi-thread workloads. That probably is worth a price bump. I mean, 8 cores in the 5800X is within kissing distance of the 10 cores in the Intel 10850K. And the 10850K is more expensive by about $50 at the time of this video, although I'm sure that's going to fluctuate, $50 to $80, something like that. But it's, more expensive than the 10700K, which is 8 cores. But it's also faster than the 10700K too, the 5800X. So for me, the availability of the 3000 series Ryzen CPUs is sort of what's gumming up my thinking here. Because if it were me, and I were faced with a choice of getting the 3900X at, let's say, at least $100 less than the 5800X, I'd probably jump on the 3900X instead of the 5800X. The only scenario that I wouldn't would be is if gaming performance at really high frame rates was more important to me than productivity. I mean, for GPU-bound game performance, scenarios, the performance on the 3900X was already pretty great. I mean, Ryzen was basically already there in terms of game performance. And 12 cores, that's really awesome. The 5900X, on the other hand, if you have the budget, I'm sold. It's no compromises. It's a desktop CPU that has great features for work and play. Oh, you should note one thing to be aware of. If you have a 400 series motherboard, they don't yet support 5000 series CPUs. They will probably around January because AMD needs time to work with motherboard partners to qualify those older motherboards. The 5000 series motherboards have all of the testing and design considerations necessary to support these CPUs. They haven't increased in TDP or anything like that. It's 105 watts TDP across the board, except for the 6-core, which is only 65 watts. But 6 cores, 6 cores is the new 8-core, maybe. I don't know. I'm going to do some small form factor builds as soon as I get my hands on the 6-core. Our guide for flashing your BIOS without a CPU, if your motherboard supports it, is also something you should consider consulting, because if you get a motherboard and it won't post, chances are you just need to update the BIOS, at least a 500 series motherboard. Certainly for a 400 series motherboard if you're watching this in January. Can you imagine where we're going to be in 3 years? I mean, AMD is on a tear. If they continue this momentum, 3 years, it's going to be insane. It's going to be utterly insane. AMD may yet save us from ARM on the desktop. x86 may actually be able to continue existing. Once again, last time they saved us from Itanium. Up on Patreon and Floatplane are even more videos on Zen 3. They'll be out on the YouTube channel in just a few days, but if you can't get enough, join there. Thank you all for your support. It's been quite a journey. I'm excited to see how Intel responds to all of this, because all of us are going to benefit from the competition. If you want to see how the 5800X works in Linux, be sure to check out the Level 1 Linux channel, where I do a deep dive with Linux performance on the 5800X and the 5900X. Get some performance and benchmark comparisons there in a Linux context. But, can you imagine, is Intel going to be the value proposition? Are we going to see like the Intel 8-core for like $250? I mean, Micro Center was selling the 9900K for like $299 the other day. Ooh boy, competition's alive and well. And while there's not really right now any really competing CPU with the 5000 series CPUs, if you have to have the fastest thing, it's close. It's pretty close. But maybe the next generation, maybe the generation after that, I don't know. But competition's alive and well. I love it. I'm Wendell. I'm signing out, and I'll see you later.